Welcome back all. Welcome back all. Welcome my dear students. Welcome. A very happy good evening to all of you. कैसे हो आप लोग? How are you all? You're all welcome beta. You're all welcome. Now beta, today we are going to start another new chapter, heat exchanger. Beta, this chapter is very important if you are seeing this chapter for interviews. So very important chapter my dear students. This is very important for interviews. Very important for interviews. Before starting, I want to clear beta our previous chapter fins. Everyone enjoyed, completed without any doubts. And also beta, please confirm me audio and video is crystal clear to all of you. Hello beta, very happy good evening beta. You are all welcome. First write beta crystal clear. CC in comment section. Audio and video is crystal clear to all of you. Am I audible? Am I visible beta? Okay, very good. So everyone enjoyed our last chapter, fins. So revise and also complete homework numericals in my next doubt clearing session. In just a few minutes, I will take to revise full fin chapter. Full fin chapter in just a few minutes. Okay. So हम चाहेंगे तब तक आप सभी लोग everyone please revise it properly. Okay. And also beta please try those two homework numericals. Very important. Okay. And if any doubt, like if you feel anything is missing there, you can ask me in Gate Chemic Learning App chat section in your app. Okay beta? Crystal clear sir. Okay beta. So now we are going to start heat exchangers. And this is very important class. So once again, you are all welcome. As you all know, this is Gaurav Srivastav Sir from IITBHU, Educator Head Gate Chemic Learning App, Gate Chemic Institute. With 12 plus years of teaching experience, you can say most experienced educator of this Gate Chemical Engineering field. With more than 15,000 paid students, overall more than lakh of students. If you are going to add YouTube and everywhere, and more than 2100 hours already taught in offline and online classes. Now beta I am going to start. निशांत आर सर जो शिवांशु ने डॉट पूछा था प्लीज एक बार प्लीज आस्क मी अगेन बेटा प्लीज आस्क मी अगेन व्हाट यू वांट टू आस्क I am waiting for your question, then we will start this chapter because in the mid of any chapter you can't ask other chapters doubt. You can ask आइदर एट द स्टार्ट और एट द एंड. आप शुरुआत में पूछ लो ओके, लास्ट में पूछ लो ओके. हीट एक्सचेंजर शुरू हो गया तो उसके बीच में नहीं पूछोगे, फिर आपको डाउट क्लियरिंग सेशन का इंतजार करना होगा. ओके, वेरी हैप्पी गुड इवनिंग बेटा, वेरी हैप्पी गुड इवनिंग टू ऑल ऑफ यू. प्लीज आस्क मी बेटा, आई एम वेटिंग फॉर योर कमेंट. स्टिल आई एम वेटिंग बेटा. Nishant, sir, if H1 is greater than H2, okay. So if H1 is greater than H2, this is doubt of Nishant. This is doubt of Nishant as well as Shivanshu. Shivanshu Rai. Okay. So this is doubt. Okay. So if H1 is greater than H2, it means Q1 convective is greater than Q2 convective. Q1 convective is greater than Q2 convective. Then T1 should be greater than, that means now you are giving conclusion here. This is your conclusion. Correct or wrong? Wait, I will tell you. So T1 should be greater than T2. Beta, this is very silly doubt, but don't worry, you can ask me any type of doubt. Silly doubt हो, जैसा भी doubt हो, doubt तो doubt होता है बेटा. Doubt is doubt, and you must clear, complete everything with 0% darkness. Only you will be capable to remember concepts and everything if you are learning with 0% darkness. Now, Nishant, I want to ask one beautiful question, beta. Beautiful question. Just tell me one thing. We have two plates, beta. This is plate number 1. This is plate number 2. Okay? Okay, wait, beta, wait. Don't worry. I am not going to use any equation here. आपको समझाने के लिए कोई इक्वेशन यूज करने का रिक्वायरमेंट नहीं है हमें. I no need to use any equation to change your conclusion. Just tell me one thing, beta. Both plates are attached to a surface. That surface giving a constant rate of heat flow to these plates. Suppose those are heated. Okay. Maybe if you don't want to give heat supply, no need to give heat supply to these plates. Just initially assume that this one at some temperature T1, this one at some temperature T2. Now, my dear students, just tell me, forget about heat transfer from bottom. I will add it, don't worry. And now this one I am giving on the top of this plate water. And here on the top of this plate, air is flowing. Air is flowing. If we are going to compare heat transfer coefficient of water and air, can you tell me, beta, which one is larger? H1 is larger or H2 is larger? I am waiting for your comments. Everyone, beta, please tell me. H1 or H2, which one is larger? H1 or H2, which one is larger here? In plate number 1, above plate number 1, water is flowing. Above plate number 2, air is flowing. Just I want to ask beta H1 or H2. H1 is greater than H2. Okay. That means this statement, your first statement, is satisfied. Now just tell me one thing, my dear students. In which case the rate of heat transfer or the rate of heat loss is larger? Is it Q1 or is it Q2? Definitely the heat is going to the surrounding via Newton's law of cooling, HA delta T, no problem. Just tell me. Because in both cases, the temperature of water and temperature of air, I am not going to change. I am not going to change temperature of air as well as water. Okay. Initially, suppose both are at the same temperature. Suppose initially both are at the same temperature T and T. Okay, beta. Now tell me after some time, once heat is started flowing, then just tell me in which case the rate of heat transfer is more, Q1 or Q2. Still I am waiting for your comments, my dear students. Q1 or Q2, which one is larger one? Tell me, beta. Tell me which one is larger one. At time t equals to 0, this is t. At time t equals to 0, this is also t. Q1, yeah. Now very good, beta. So your second statement is also satisfied. Now just tell me one thing, my dear students. After time t, if this plate reaches temperature T1, this plate after time t reaches temperature T2, which one is larger? Now tell me, T1 or T2, which one is larger? Come on, beta, everyone, please tell me which one is larger one. T1 or T2, which one is larger? Is it T1 or is it T2? Still I am waiting. Come on. T1 or T2, which one is larger? T2 is larger than T1 now. Your conclusion, that means your conclusion is wrong. 100% where rate of heat transfer is more, the surface temperature will be low. So here 100% because Q1 is larger, so definitely here T2 is larger. Is it crystal clear beta? Doubt clear ho gaya na? Tell me everyone, is it crystal clear? Shall we move forward beta? Shall we move forward with heat exchanger? Beautiful, mind-blowing, superb lectures. Come on beta everyone, tell me. Shall we move forward beta? निशांत एक न्यूमेरिक डिजिट से एग्जांपल बेटा यू कैन टेक एनी न्यूमेरिक डिजिट यहाँ पे आप ऐसे सोचो ना दिस इज अ प्लेट एक बार इस प्लेट को आप ऐसे जगह ले जाओ जिससे ये हीट ज़्यादा लॉस करे और एक केस में कम हीट लॉस करे तो बेटा जहाँ ज़्यादा हीट लॉस करेगा वहीं तो ये जल्दी ठंडा होगा ना तो जहाँ ज़्यादा तेज हीट लॉस कर रहा है वहाँ इसका टेम्परेचर ज़्यादा डाउन हो गया जहाँ कम हीट लॉस कर रहा है वहाँ इसका टेम्परेचर कम ड्रॉप होगा भाई सरफेस से ही तो आपका क्यू कन्वेक्शन हो रहा है सेम पिछले केस में कंडक्टिव हीट ट्रांसफर जो यहाँ से इन कर रही थी वो तो दोनों केस में सेम थी फिन में जब दोनों केस में सेम थी तो भैया सीधी सी बात है जो सरफेस तेजी से हीट लॉस कर रहा है वो सरफेस फिन का ज्यादा ठंडा हो जाएगा ना इन कंपैरिजन टू अदर वन अभी क्लियर हुआ क्या बेटा आई एम यूजिंग योर ओन लैंग्वेज सो आई होप नाउ यू बेटर अंडरस्टैंड बेटा निशांत इज इट क्रिस्टल क्लियर नाउ just explained especially for you. Now it is diamond clear. Very good, fantastic. Now tell me beta, what is this? Can you tell me what is this? What is this? Steam, hot fluid, outer pipe, inner pipe, hot fluid out, cold fluid in, cold fluid out. What is this beta? Shell and tube heat exchanger. No, Ankesh, you are absolutely wrong. Yeah, Jayant, it is a heat exchanger. But can you tell me the name of heat exchanger? Sir, sometimes local language preferable hota hai. Okay, beta, don't worry. You can ask doubt in your own language, in any language. In any means, you don't use Tamil. I know only two languages, Hindi and English. Okay? So you can ask your doubts in Hindi language too. Even if this is English based, don't worry. आप हिंदी में डाउट पूछ सकते हो. Okay? Doubt, use your own language. Yes. This is double pipe. Very good, beta Lakhan Kumar Pandit. And Jayant, this is double pipe heat exchanger. Simplest type of heat exchanger, beta. Double pipe heat exchanger. This is simplest type of heat exchanger beta. Simplest type of heat exchanger. Simplest type of heat exchanger. As in this heat exchanger we are going to use just two pipes. How? Don't worry, I will tell you. My dear students, can you give me a beautiful definition for heat exchanger? Not for double pipe heat exchanger, for all heat exchangers. Just give me definition of heat exchanger. I am asking in interviews that define heat exchanger in maximum of one or two lines. What is heat exchanger? Okay, I'm waiting for your comments. I'm not in hurry. Okay, so give your definition. What is heat exchanger? How you are going to define heat exchanger? Almost, Nishant. Almost every PSU's heat exchanger, yeah, beta. Not your, you can't use almost. In all PSUs, you can see heat exchanger because in every PSU, you need water, and even cooling tower is a type of heat exchanger. Okay. Ankis, adiabatic device used to exchange heat between two fluids. Very good, beta. Very good. Ankis, your definition is absolutely correct. I just want to hear one thing, that is adiabatic. Beta, if you want to see in reality, nothing is perfectly adiabatic. Adiabatic means what? Adiabatic means no heat transfer. Adiabatic means what? Adiabatic means no heat transfer. This is adiabatic. Adiabatic means what, beta? No heat transfer. Oh my god. Sir, you are saying this is a heat exchanger and now you are saying no heat transfer? Yes, beta. Heat exchanger is not going to exchange heat from surrounding. इसका सराउंडिंग से कोई मतलब नहीं होता. So heat exchanger is an adiabatic device that is used to transfer heat between two fluids by direct or indirect contact. Oh my god, that means fluid can be interacted with each other as direct contact or indirect contact. Direct contact means they will mix in each other. Direct contact means they will mix in each other. Like if you have a glass of milk, this is milk. Your mother asked to please, beta, take it, and this is very hot. So, if you are going to towards your fridge and going to add some part of cold milk to this hot milk, beta, the temperature of hot milk will drop down. Here also we are going to exchange heat between a hot and a cold milk, that is fluid. So here you can see the fluids, two fluids here are physically mixed in each other to exchange heat. Fluids are mixing in each other to exchange heat. Whereas maybe you can use some other technique. Take this hot milk and take one big vessel that is filled with cold water. Now, beta, see here. Again, heat will be transported, exchanged between this hot milk and cold water. And similarly, here also temperature of this hot milk will drop down with respect to time. Okay. So they can be in physical contact or just in thermal contact. So here they are in physical contact, physical, physically mixed, and here they are just in thermal contact. They are just in thermal contact, physically unmixed. Okay, so physically mixed, that means this is direct direct type heat exchanger, and only in thermal contact, that means indirect type heat exchanger. Okay, beta. Now Jayant asked something. Sir, experiment used to trans. Okay, okay, you are giving definition. Nishant, sir, cooling tower example. Yes, beta, cooling tower can be example of direct type heat exchanger. Lakan Kumar Pandit, sir, double pipe heat exchanger, why contact surface area is small? Don't worry, beta. After this slide, I will discuss double pipe heat exchanger. Then, if you feel any doubt, ask me. Okay, beta, Lakan. Now, you can see here condenser, ejector. But before that, beta, one thing you must clear. If your heat exchanger is an adiabatic device, because here this glass is not in adiabatic in nature, because it is also exchanging heat with air. Here also it is exchanging heat with air, and here also with air. With air. So all fluids are also exchanging heat with surrounding fluid. So if you are going to define heat exchanger, because our all derivations are based upon this assumption that our heat exchanger is an adiabatic device. So our in our heat exchanger only this is assumption, beta. This is not in reality. This is we are going to assume only fluids can exchange heat. No interaction with surrounding. No interaction with surrounding. Okay, beta. No interaction with surrounding. So simply you can, that means in one line you can say anything, any device in which you are seeing in industry the heat is going to exchange between hot fluid and cold fluid, you can say as a heat exchanger. Condenser. What is condenser, beta? Like if you are using a pipe, inside this pipe, suppose outside steam is there, and inside this pipe, if we are going to supply cold water, then what will happen? Steam will start condensing and drop down. You can see, beta, steam and cold water is in indirect contact. This is indirect contact. Like ejector. What is ejector, beta? See, this is a typical diagram, simplest diagram of ejector. Suppose from here, from this side, cold fluid is flowing, and here some hot fluid is present. Now, due to decrease in area, here velocity will be increases. That's why pressure will be decreases. So now, due to less pressure here, this hot fluid is at higher pressure. This fluid will be sucked by this cold fluid, and they will mixed also, and they will also exchange heat. Now you can see, beta, this is an example of direct contact type heat exchanger. Okay, beta. So basics clear hai, fundamentals are crystal clear to all of you, beta. Is it clear? Is it clear? Now Lakhan asks, sir, why we are going to use heat exchanger, double pipe heat exchanger only, why small contact surface area is available for double pipe heat exchanger? Yeah, beta. Reboiler is also a type of heat exchanger. Jayant Kumar Reddy. Reboiler is also a type of heat exchanger. Okay, because in reboiler, without using a part that is termed as heat exchanger, you can't obtain vapor. Okay. Now see, first simplest type of heat exchanger we are going to learn, that is double pipe heat exchanger. After few lectures, I'm not going to give you classification first. हम पहले आपको classification जानबूझ के नहीं दे रहे, हम कुछ चीजें आपको पढ़ाना चाहते हैं ताकि आप खुद जान जाओ how we are going to classify them. Generally in all chapters I am giving you classification first, then going to explain. But in heat exchanger, I'm not going to give you classification first. I'm going to start like a story first. So this is double pipe heat exchanger. This is simplest type of heat exchanger, beta. This is simplest type of heat exchanger. Simplest type of heat exchanger. This is simplest type of heat exchanger, but you can use this heat exchanger only if heat transfer area required is less. You can say a typical value. This is a typical value beta. This is just a range. The maybe you can see more than 150, like 155, or you can see like 80 feet square. Just this is a typical range. Most of the double pipe heat exchanger, if you are going to see, then you will get this surface area, not surface area, heat transfer area. Okay, so this is just a typical range, that is 100 to 150 feet square. Why we are doing this? Why we can't use? Now Lakhan, your answer beta. Lakhan Kumar Pandit. Now why we can't use double pipe heat exchanger for the cases where we want more heat transfer area? Because in that case beta, your pipe will be too long. It will take a very large space for installation. But we can use for same surface area, same higher value of surface area, we can use another type of heat exchanger. Okay, I am going to tell that name. जानते भी हो आप लोग, that is cell and tube heat exchanger. That heat exchanger will give us larger value of surface area even for a smaller size. So which one is economic in nature beta? You are going to use large space, land cost is there. You are going to use large space, or you are going to use less space for installation. Definitely you will choose less space for installation. So this is a very big reason why we can't use, or why we don't want. We can't na bole yahan. Don't tell we can't, just tell we don't want. We don't want to use double pipe heat exchanger if heat transfer area required is large. A typical value you can say if larger than 150 feet square. Okay Lakhan, is it crystal clear beta? Is it crystal clear? Sir, your examples are too basic, which is too easy to understand. Thank you beta. Now please tell me everyone, till now everything is crystal clear beta? Shall we move forward? Shall we move forward, my dear students? I am seeing your comments, everyone. Beta Lakhan, you are crystal clear. Okay, very good. Nishant asked, sir, who designed heat exchanger? This is something like historical question. Okay, beta. Heat exchanger generally designed around 19th of century. When starting of 19th of century, it was nearby 1880s. And the first heat exchanger was plate type heat exchanger in Germany 1878 by Albrecht Drake. नाम लेके क्या किया? लिख दें? You want this name? Okay, wait. See here. First invented by in 1878 in Germany, and first type was plate type heat exchanger. I will discuss later plate type. इसके बाद धीरे धीरे इसके अलग अलग टाइप्स आने लगे. प्लेट टाइप हीट एक्सचेंजर. Okay, so first developed plate type heat exchanger. Albrecht Drake. Okay beta Nishant, now shall we move forward? Okay beta Lakhan, very good, fantastic, mind blowing, super. Okay, now we were talking about double pipe heat exchanger. As now you all know that this is a simplest type of heat exchanger that was used only and only when heat transfer area required between 100 to 150 feet square. Now here you can see it's simple diagram. See beta here, this diagram. Clearly you can see two pipes are present. If you are going to see two pipes, cross section, like this is your first pipe beta, this is your second pipe. This is your first pipe, this is your second pipe. Okay, I am just showing you one cross section. Okay, like A dash. So this is A dash. Okay, A dash. Now this space between two pipes, here two pipes beta, you are using two pipes, but one thing must sure, that the center of both pipes are same. That's why I am saying here we are using two concentric pipes. Two concentric pipes. We are going to use here two concentric pipes. And this space between two pipes is known as annular space. Annular space. So one fluid is flowing in this annular space, and the second fluid is flowing in the inside tube. Second fluid is flowing in this inside tube. How they are flowing? Wait, I am going to show you. See, in this annular space, this is your fluid flowing. You can see here beta, fluid flowing in this direction. This is your annular space. This is your annular space in which fluid flowing from left to right. In which fluid flowing from left to right. Okay. Now, right to left. Now fluid is flowing from right to left. Now again from left to right, because we can't use a straight construction. Why? It will take very large space. It will take very large space. Now you can see beta, this fluid exited. This side you can say as shell side, similar to analogous in nature, just like in shell and tube heat exchanger. But this heat exchanger is not termed as shell and tube heat exchanger. That is different. Double pipe heat exchanger is different. So here this is shell side, just written for analogous nature. Okay, just written for analogous nature. You can say annular side fluid. It is much more correct word. Annular side fluid. Okay. Now see, second fluid, from where entering, from where we are going to enter that second fluid. See here, inside tube, inside tube, from left to right, from left to right, from left to right, from left to right, left to right, right to left, then again left to right, and this out. Now you can say beta, they are not in any type of physical contact, but they are in thermal contact. That means they can exchange their heat. So now if this fluid, suppose I am assuming this as my hot fluid inside, so this is hot fluid in and this is hot fluid out. I think yellow is not visible. Okay, yellow is not visible. So this is hot fluid in, hot fluid in, and this is beta hot fluid out, hot fluid out. Okay, Similarly, in annular site, this is cold fluid in, cold fluid in, and here you can say this is cold fluid out. Now, every time when you are going to check beta, you can see they are flowing in different directions. Like if hot fluid is flowing from left to right, then cold fluid is flowing in that region from right to left. That means always they are in opposite directions. They are flowing in opposite directions. And if this type of flow pattern obtained in any chemical industry, then it is termed as beta what? Counter current flow. Counter current flow. This is termed as beta what? Counter current flow. Sir, so we are using always counter current flow in industry. No beta, other flow patterns are also available. Other flow patterns are also available. Like maybe both are in same direction. Then it is termed as co-current flow. Co-current flow, or it is also known as parallel flow. Parallel flow. Sir, only these two flow patterns? No, one more. They can be interacting in this way. So what is this? This is beta cross flow. So these three types of flow pattern you can see, you can also see during the study of heat exchangers. These are what? These are flow patterns. Flow patterns. Is it crystal clear to all of you, my dear students? Shall we move forward, beta? Please tell me, everyone. Till now, everything is crystal clear. I am seeing your comments. Everyone, beta, please tell me. Shall we move forward? Now, one very important thing, beta. Generally, if you are going along with standard, one thing is crystal clear here, that here two concentric pipes, and these are indirect type heat exchangers. And here beta, if you are going to check the dia of inner pipe to dia of outer pipe, this is inner pipe dia, inner, this is outer, and for both pipe this is what? This is for inner pipe or outer pipe, generally we are using outside dia. So generally I am giving you just standard. In industry, it can be designed in different dimensions by process engineer according to need. So the standard is, if you are using 1.25 inch inner pipe, then outer pipe dia can be 2 inch. If inner 2 inch, outer can be 3 inch. If inner 3 inch, outer will be 4 inch. That means the diameter difference between outer and inner pipe is generally 1 inch. This is generally. This is not always. I am using word generally. सामान्यतः यह होता है इतना. यह हमेशा नहीं होता है. Okay, beta. Is it crystal clear to all of you? Okay, very good. Now, one thing you must clear, beta. One thing you must clear, that you can see here, beta, a typical diagram again. If this is a solid wall, suppose this is a solid wall. This is a solid wall. And one side of a wall, fluid 1 is flowing. and on the second side of this wall fluid 2 is flowing. Okay beta. Nishant asked, sir, why hot fluid feeded from top side and cold from bottom? Beta, don't worry, I will discuss flow patterns, why we are using hot fluid in inner tube, why we are not using hot in outer. Okay, which fluid where you are going to feed, all things I will discuss in detail, so don't worry. ओके, वहां से इंटरव्यू में क्वेश्चन उठते हैं बहुत खतरनाक वाले, और उतना ही खतरनाक हम आपको पढ़ाते हैं वो टॉपिक भी. यू कैन सी माय प्रीवियस फुल रिकॉर्डिंग ऑफ हीट ट्रांसफर ऑपरेशन, प्रीवियस वर्जन. इसके पहले भी हीट ट्रांसफर जो खत्म हुई, रिकॉर्डिंग इज अवेलेबल देयर, so you can go through PDF files, you can check there beta. A big heading is there. Okay, only on flow patterns, that in which side which fluid why we are going to feed, you will see in detailed manner. And also I will ask you that you can now ask any pattern of your choice, any fluid of your choice. I will tell you which one is ideal in nature. Okay beta Nishant, how to represent cross flow in double pipe heat exchanger? Beta, don't worry. Okay, in double pipe heat exchanger, if you are going to see, then just here in this region you can see that cross flow is happening in this region, in this region. Okay, cross flow is happening in this region only. So generally in only single heat exchanger you can see more than one flow patterns also, beta. More than one flow patterns also you can see. And also I will design in future, in subsequent lectures, you can see in just one heat exchanger I will draw like counter cross, all will be there. Okay, so because just negligible part having cross flow, so I'm just neglecting there, but I'm neglecting, but in industry for that neglection I will use correction factor, that is total name is LMTD correction factor. So all topics are present but not in this lecture number 1. This is introductory lecture of heat exchanger. Okay Lagan, Jayant, is it clear beta? Yeah beta, it is for interview. Flow patterns, which fluid on which side is very important for interview. Okay, or only because of this topic in past lots of my students selected in lots of places and they told me that sir, they asked me this question. Okay, that this fluid where you are going to feed, inner outer, inner out, cell side, tube side, you will be capable to give answer for infinite number of fluids, for any type of fluid, in simple language you can say. Okay beta, now see here beta, if we have a solid wall and this side one fluid is flowing, this side one fluid is flowing, and if the temperature of wall and, or you can say if the temperature of this fluid is T1, this fluid is T2. Okay, this is also wall is having very large in length. Okay, that means always these two fluids are separated with each other, always separated with each other, they are not going to mix physically. Okay, now beta, if T1 is greater than T2, then definitely you can say that heat is going to travel from this side to this side. This is what, this is Q, this is Q, rate of heat transfer from left to right side. And when it starts flowing beta, what will happen, it will feel first one resistance here. If this side heat transfer coefficient is H1 and the surface area is A1, then this resistance will be 1 upon H1 into A1, if this side's surface area is A1. Now again it will feel one more resistance here. This is resistance number 1, this is resistance number 2, and again this is resistance number 3 beta. So the second resistance is conductive resistance, that is L by Ka in similar, in general terms. Now again it will feel one more, that is 1 upon H2A2. If this side heat transfer coefficient, I am assuming EH2. And this side temperature is T1, this side temperature is T2. Now if you want to check the rate of heat transfer, either you can join this, either you can join this if you know the interface temperature here, or you can join like this if you know these two temperatures, or you can join like this if you know these two temperatures, you can join like this if you know these two temperatures, you can join like this, in any manner beta you can join 2 points and you can Calculate what should the value of Q. By all techniques, by all ways, if we are talking about steady state rate of heat transfer, all will be same. But, see, every time you are telling me that sir on this point, this point, this point, this point, everywhere, this, all this point, temperature is T1. All this point, temperature is T2. But is it the same in heat exchanger? Okay, we will discuss it after 2 minutes. Just see this heat exchanger beta. Here, I am going to give one fluid on this side, inner tube side fluid. This is flow pattern of inner tube side fluid beta. This is just a support. You can say stand. No, exit. Now see, second fluid that I am going to fed to the annular side from here. Now see, this is direction of annular side fluid. Okay beta, they are not in physical contact beta. One thing you must clear, they are not in physical contact. One is in annular space and second one is in inner tube. Second one, no, here it will turn from here. Now in this case beta, you can see, first thing beta, they are in indirect contact. Indirect contact means only in thermally in contact. Indirect in contact, indirect contact. Okay, now here beta you can see every time they will be in same direction. That means this heat exchanger you can define as co-current or parallel current, co-current or parallel current, co-current or parallel current, double pipe heat exchanger. Okay beta, is it crystal clear? It was from interview Nishant in Aarti Industry. Okay beta Nishant, क्रैक कर दिया था ना मस्त. Okay, my lots of students are also there in Aarti Industry. I think minimum number of students 20 plus. Okay, in previous few years, just in IT industry from their colleges. ये colleges में जाती है, colleges से उठाती है. Now see beta, if you are going to see this double pipe heat exchanger, then see one beautiful thing I want to show you here. Very, very important beta. Suppose my hot fluid is entering from here in tube side at some temperature 120 degrees Celsius. And as you asked sir why we are giving hot fluid from top, आप इस यहाँ पे एक reason you can say like when it was going towards bottom, its temperature drops down, and if temperature drops down its density will be increases and it will help in natural flow pattern, natural flow. भाई अगर आप ऊपर गर्म दे रहे हो, जैसे से वो नीचे को आएगी, नीचे आते आते वो क्या हो जाती है, हल्की हो जाती है. ठीक है, सो ये एक रीजन हो सकता है. बट यहाँ जो आप देख रहे हो हियर इन दिस डायग्राम, नथिंग इज in on up side or in bottom side. The heat exchanger is on the bottom, just on a horizontal surface. Okay, so here I am giving this. If it is in vertical, then try to give 120 degrees Celsius fluid from top, okay, and towards bottom, so that natural flow pattern will be there, natural circulation pattern will be there. It will help you, density will help in your flow. Now Here I am giving 120 degrees Celsius fluid from this side. Definitely it is in contact with some cold fluid. This is I am assuming hot. Okay. This is I am assuming hot, and this side I am assuming some cold fluid. Okay. That is suppose available at some 20 degrees Celsius. Now what is going to happen here with that? This inside tube 120, after some time, after losing some heat, the temperature suppose approaching 110 degrees Celsius. After some time, after some more distance, the temperature is now 100 degrees Celsius. This side maybe temperature is now 95 degrees Celsius. This side temperature may be now 84 degrees Celsius. Now temperature may be 75 degrees Celsius. Now temperature may be 67 degrees Celsius. Now here at the exit it may be 55 degrees Celsius. I am giving just a typical value beta. I am giving you a typical value. Okay. Now see this cold fluid entering at 20 degrees Celsius. Entering at 20 degrees Celsius. Now it is going towards right. Okay. So after some time, the temperature here I am checking and note down as 24 degrees Celsius. After some time here I am checking temperature, I got it is now 31 degrees Celsius. Here I am seeing and got it is now 37 degrees Celsius. Here it is now 41 degrees Celsius. Here now it is now 44 degrees Celsius. And at the exit it is now at 45 degrees Celsius. I am giving you just a typical value beta. Now just see here. Every time at every location, just I want to check my delta T. Here the delta T is 67 minus 20 is 47 degrees Celsius. 75 minus 24. Here our delta T is 51 degrees Celsius. 8431, here delta T is 53 degrees Celsius. 9537, here our delta T is 58 degrees Celsius. 141, here delta T is 59 degrees Celsius. 110 and 44, now our delta T is how much beta? It's 66 degrees Celsius. 120 and 45, here delta T is now 75 degrees Celsius. Oh my god. Which delta T? Here at the start, the delta T was just 35 degrees Celsius. Now, which delta T are? We should take which delta T if we want to calculate by using this formula, that is Q equals to T1 minus T2 and whole upon 1 upon H1A1 plus L by Ka plus 1 upon H2A2. So which T1 and T2, which temperature should be used in heat exchanger? कौन सा temperature आप use करोगे? Which you are going to take as T1 or you are going to take as T2? Which one? So it's a very big task for us, because our conclusion, beautiful conclusion that we got with the help of this diagram is delta T is not same at every cross section, at all cross section. It is not same beta. It is not same. Then what to do? You know one thing we already learned, that if we are going to show these all resistances at just one resistance, and these all capability of transfer to heat transfer coefficient and thermal conductivity etc as just one parameter, then that parameter is termed as overall heat transfer coefficient. Like here you can also write this as U, A delta t. Here, the delta t is t1 minus t2. But now in this case, which t1 or which t2? And here also, if you are going to use inside area, then it is ui ai. If you are going to use outside area, then you have to use a naught, u naught, a naught. Okay. But here the big problem is which delta t we are going to use. The answer is very, very easy. And I will also show you why I am using that mean, because I am going to take an average. You know na, arithmetic mean, arithmetic mean of A and B is written as A plus B by 2. Similarly, geometric mean of A and B can be written as A multiplied B is square root. Similarly, my dear students, one more mean is there, that is log mean. Log mean of A and B. It can be written as A minus B upon ln of A by B. Or you can write B minus A upon ln of B by A. Both are same. See beta, minus taking common, multiplied in numerator, you will get B minus A upon ln of B by A. So here we are going to use log mean. So here we take log mean of temperature difference, that is termed as log mean temperature difference. Why we are taking this beta? Why we are not taking arithmetic mean or geometric mean? Don't worry, I will prove with the help of beautiful derivation in my subsequent lectures, that is termed as derivation of LMTD. The name of that lecture will be derivation of LMTD. So here we can use this formula, that is Q equals to UI AI delta T LM, log mean temperature difference, or you can write U naught A naught delta T LM. What is AI? AI, if you are going to take this inside surface area. What is A naught? If for the same inner tube you are taking outside surface area, this is AI, this is A naught. That is inside area of inner tube, and A naught is outside area of inner tube. Okay, my dear student, shall we move forward? यहाँ तक सभी को clear है बेटा? Please confirm बेटा. Everyone crystal clear? Shall we move forward? Tell me बेटा everyone. Shall we move forward? I hope everything is very, very easy. सब कुछ आसान लग रहा है ना? Everyone? Okay. Now please draw these two diagrams. First thing I want to tell you beta, delta T LM definition. So delta T LM definition is what? Delta T1 minus delta T2 and whole upon ln of delta T1 by delta T2. Very, very easy formula. What is delta T1? What is delta T2? See beta. Here this is, you can take as delta T1. Exit temperatures, here this you can take as delta T2. Anyone you can take as T1 or anything you can take as T2. So here you can say 35 and 75. Okay. Now see two diagrams here. First, suppose I am representing for counter current flow pattern, and a second one for co-current. Co-current is also termed as parallel current flow. Parallel current. Okay. And one more good news for you beta. I am coming in New Delhi for approximately 20 days to 1 month. So if you want to meet me in New Delhi, you can call me. Okay. Now, counter current, co-current or parallel current. This is a shell side fluid. Okay. Wait, first one is counter current, so just draw it from other side, or you can show same thing for both cases, like here entering, exiting. This is entering at TCI temperature, this is exiting as TC naught temperature. Okay, clearly this is in this direction, and here you can write in similar way. Yeah beta Vibhash, new offline batch is going to start in New Delhi, and I will give you details on call as well as on WhatsApp, personal WhatsApp. You can ask me, but here in this lecture, first see only this heat exchanger and think about heat exchanger this time. Just try to understand, because this topic is very important beta, and it will take approximately 7 to 8 lectures minimum. Okay, or maybe up to 10. Now, या ऑनलाइन क्लासेस एज यूजुअल बेटा, जैसे अभी चल रही हैं ऑनलाइन क्लासेस में आपको कोई डिस्टरबेंस नहीं आएगा. इट विल रिमेन सेम, जैसे अभी चल रहा है वैसे ही चलेगा तब भी. ओके, बिकॉज ऑफलाइन क्लासेस आई विल टेक ड्यूरिंग डे टाइम बिफोर 6 p.m. and online classes I am taking after 6 p.m. so दोनों आपस में एक दूसरे से लड़ेगा नहीं, डोंट वरी. ओके, ऑफलाइन ऑनलाइन बोथ आर separately going in future. Now see here, if from this side your hot fluid is entering at THI temperature and exiting as TH naught temperature, and in this diagram this is entering from left side at THI and exiting from left side at TH. Oh my god, that means for same design, if just I am going to change flow pattern or inlet side, I can change, I am able to change counter current flow to co-current flow. देखा बेटा कितना मजेदार. So maybe asked in interview that we are going to do any special design for counter pattern. No sir, we can use same heat exchanger for as a counter flow as well as co-current flow. हम सेम को ही दोनों तरीके से इस्तेमाल कर सकते हैं. Now see the first diagram here. Suppose this is for counter current, this is for counter current, and the lower one is for co-current. Okay, now see, just I want to draw temperature profile here. Okay beta, very easy. So in co-current, this is your THI. So hot fluid loses its heat, and suppose like this, a flow pattern like this, and this is a cold fluid. So this is TH naught, this is TCI, and this is TC naught. Okay, similarly here this is co-current. Okay, so co-current means hot fluid entering from this side like this, cold fluid entering from this side like this. This is at THI, this is at TS naught, this is at TCI, this is at TC naught. One more thing beta, you can see with the help of these flow patterns that the delta T will be more uniform in counter current in comparison to co-current. You can see here delta T distribution is more uniform, or you can say more, don't use uniform, nearby, or write like delta T distribution is more nearby uniform for counter flow pattern, counter flow pattern in comparison to in comparison to co-current flow pattern. Okay beta, is it crystal clear to all of you? This conclusion is crystal clear beta? Yeah, you can say that a thermal stress is more in this co-current flow. If you are going to write thermal stress, then thermal stress is more in co-current. In co-current flow, you can see more thermal stress in comparison to counter current flow. Crystal clear? Okay, very good beta. Now, as I told you, these are exit side delta T. We are seeing at exit side. So here this is termed as delta T1. Here this is termed as delta T2. So delta T2 is TH naught minus TCI. Here this is delta T. You can say T2, T1, any side you can represent as 1 or 2. Okay beta. So suppose here I am using this as again T1 or T2. It's your choice. So suppose I am writing T1. So this is TH1 minus TC1, because you can write delta T1 minus delta T2 upon ln of delta T1 by delta T2, और you can write delta T2 minus delta T1 upon ln of delta T2 by delta T1. अगर यहाँ पहले delta T1 आएगा तो यहाँ पहले delta T1 होगा न्यूमरेटर में, अगर यहाँ delta T2 आएगा तो न्यूमरेटर में delta T2 होगा. Just you are taking minus from numerator and denominator. And here delta T1 is THI minus TC naught. Here delta T2 is TH naught minus TC naught. Oh my god. So we are going to use different formulas? No beta. The delta TLM definition is same. This you are going to use for co and counter both. The same formula you are going to use. But what is the difference between these two? The definition of delta T1 and delta T2. So the definition of LMTD is same for both cases. You can give a beautiful conclusion here, that is delta TLM definition is same for co-current and counter current. Co-current and counter current heat exchangers, but the definition of delta T1 and delta T2 are different. These are different beta. Okay, is it crystal clear beta? Any doubt? Everyone is crystal clear beta? Like here, if you want to write delta T LM co, or if you want to write delta T LM counter, then see their definitions beta. Here again you are going to use same delta T1 minus delta T2 upon ln of delta T1 by delta T2, and here again you are going to use the same formula delta T1 minus delta T2 upon ln of delta T1 by delta T2, the same formula. But now here delta T1 is what? See, in co-current it is THI minus TCI. So THI minus TCI, and here what we are going to use? Delta T2 TH naught minus TC naught. So this is TH naught minus TC naught, and whole upon ln of THI minus TCI upon TH naught minus TC naught. But now if you want to write for this counter flow pattern, now its delta T1 is THI minus TC naught. THI minus TC naught, and minus here TH naught minus TCI. You can see here it's th naught minus tci, and whole upon ln of thi minus tc naught upon th naught minus tci. Okay beta, is it crystal clear to all of you my dear students? सभी बच्चा लोग को क्लियर है ना? जस्ट टेल मी एवरीवन. Now this is all about basics of heat exchanger. Now we will see more temperature distributions in subsequent lectures. But first we will learn what is cell and tube heat exchanger in my next lecture. So one thing I want to tell you beta, whenever you need more heat transfer area, you need heat exchanger. Which heat exchanger? Shell and tube heat exchanger. You can't use that time double pipe heat exchanger. Okay बेटा, so for today that's it. अब इतना ही रहने देते हैं. कल का लेक्चर बहुत भारी हो गया था, लंबा हो गया था, मोर देन 2 आवर्स, बहुत लंबा चला गया था, 2.25 घंटे के आसपास. सो आज के लिए फिलहाल इतना हल्का रहने देते हैं आज का लेक्चर. ओके, नाउ इन नेक्स्ट लेक्चर वी विल स्टार्ट फ्रॉम शेल एंड ट्यूब हीट एक्सचेंजर. ओके बेटा, एवरीवन क्रिस्टल क्लियर? चलो, बहुत अच्छी बात है. ओके माय डियर स्टूडेंट्स, सो वन मोर थिंग, maybe I will upload this beautiful lecture on YouTube. So I want to inform subscription plans to my YouTube subscribers. And you can also see for your friends beta. This time you can say a bumper offer, and I am giving name as revolution offer. I am giving name to this offer as revolution offer. And this offer my dear students, you can take up to get 2024 subscription, that is approximately now 7 months from now. 7 months from now, in just 7990 rupees, you will get all subjects live lectures, you will get all subjects recorded lectures. All subjects recorded lectures are already available in Hindi language also. Hindi means English language also. सारे सब्जेक्ट के lectures English language में भी available हैं. Okay, so live plus recording. On day one you will get 700 plus recorded videos बेटा. ओके, जिसके अंदर में आपको प्योर न्यूमेरिकल बैच इसमें इंक्लूडेड है. क्या क्या? प्योर न्यूमेरिकल बैच इज ऑल्सो देयर. Pure numerical batch is also here, and in this already 70 plus lectures are there. और हर एक लेक्चर में नए न्यूमेरिकल्स होते हैं, तो आपके लिए अभी जो ज्वाइन होता है ये सारे क्वेश्चन बैंक के फॉर्म में होंगे. सबसे ज़्यादा प्योर न्यूमेरिकल्स बैच में आपकी क्लासेस लगती हैं लास्ट के 4 महीनों में, 4 मंथ्स. सो अभी आप लोगे तो ये सारे लेक्चर्स भी कंप्लीट करोगे, और बहुत सारे आपको सेपरेट न्यूमेरिकल की प्रैक्टिस भी कराई जाएगी. मेन जो हमारा सब्जेक्ट चलता है, तब इन मेन सब्जेक्ट यू विल सी कॉन्सेप्ट्स, डेरिवेशन, देन यू विल सी lots of new numericals with lots of previous year questions. After completion of subject, now you can do more practice. From where? From our pure numerical batch. And also you will get lots of practice sets. And now I am giving all new practice sets video solution, live video solution. If you missed that solution, no need to worry, recordings are there. And if you want 1 year full Iconic Plus subscription, then its price is just 13,990 rupees. If you want to take 2-year full Iconic Plus subscription, then it is just 19,500 rupees. You can pay in installments also. For installment offer, you can WhatsApp me. For admission installments, you can WhatsApp, you can call me on 9451707049. So best content my dear students you will get here, at lowest price. You will get best content at lowest price. It's my promise to you, beta. And also one more thing, beta, in all these subscriptions, test series is also included now. From today, those who are going to take subscription, today is 22nd of July 2023. So test series is also free. All test series now free. No need to pay now separately. पहले अलग से कुछ टेस्ट सीरीज के देने पड़ते थे, कुछ फ्री होते थे, बट नाउ ऑल टेस्ट सीरीज इज टोटली फ्री with this package. Either it is gate test series, either it is pre-gate test series, either it is any PSU test series, either it is any pre-PSU test series. All test series is same, and during this period if you have any interview, then interview program is also free for you. So but I hope that still if not started, then beta you can start now, because 7 महीने भी बहुत होते हैं आपके लिए एक अच्छी रैंक प्राप्त करने के लिए, बिकॉज इन दिस प्रोग्राम आई विल ऑल्सो गाइड यू आफ्टर एवरी 10 days. गाइडेंस आफ्टर एवरी 10 days. ओके बेटा. सो बिना किसी चिंता की, सारी चिंता हमारे ऊपर छोड़ दें और फटाफट बेटा ज्वाइन होके एक बार जस्ट गिव मी वन चांस, and then beta see, I'm not only give you things for gate 2024 but in such a way कि बेटा आपकी knowledge भी, your knowledge will be also on upper side. Okay, and you can also ask me doubts on WhatsApp as well as on call. Every day I am available during afternoon session 1 to 5 p.m. बट व्हेन आई एम इन ऑफलाइन क्लास, उस समय अगर आपकी कॉल रिसीव नहीं होती है, इफ़ आई एम अनेबल टू रिसीव योर कॉल, देन डोंट वरी, आई विल गिव यू कॉल बैक मैक्सिमम विद इन 24 to 48 hours. आपका नंबर हम तब तक डिलीट नहीं करते हैं मोबाइल में की हिस्ट्री से जब तक कि हम आपको कॉल बैक नहीं दे देते हैं. ओके बेटा, सो अभी के लिए इतना ही. अभी देख लेते हैं कमेंट्स में बच्चा लोग क्या लिखा है. Most of the other students lots of interested in single subject lectures in affordable price. बेटा they can take सिंगल सब्जेक्ट इज ऑल्सो. बेटा हमारा मकसद ना यहाँ पे आपको पहले हमने बता दिया था, बहुत सारा पैसा आपसे लेना नहीं है. हमारी फीस ज़्यादा थी, हमने जब फीस रखी थी 3 year ago आई टोल्ड यू बेटा, अगर मेरे लेक्चर देखोगे यूट्यूब पे तो पढ़े होंगे, हमने कहा था 3 साल के बाद अपने प्राइजेस हम 60 से 70% डिक्रीज करेंगे. देख लो 60 से 70% डिक्रीज कर दिया. और अभी हम आपसे कह रहे हैं आफ्टर 2 year फ्रॉम नाउ, अभी से 2 साल बाद फिर से आपको बता दें, अभी से 2 साल बाद ये फीस मैं और डिक्रीज करूंगा बेटा. ओपनली इसको मैं वो यूट्यूब पे अभी अपलोड कर दूंगा. अभी तो आप पेड बच्चा देख रहे हो, अभी यूट्यूब पे अपलोड हो जाएगा आफ्टर 2 year, बिकॉज मेरा मकसद है कम से कम पैसे में बच्चों को एजुकेशन ऐसे मिले कि वो उनके अंदर का जो कैलिबर है वो हम जगा सकें. ओके, सो सिंगल सब्जेक्ट इज ऑल्सो अवेलेबल एट वेरी अफोर्डेबल प्राइस. सिंगल सब्जेक्ट इज ऑल्सो अवेलेबल. सो जस्ट टेल देम टू कॉन्टेक्ट मी directly and make sure beta we have just 2 official numbers every time for calling and WhatsApp, the above one, and only calling the below one 7398633508. इन दो के अलावा किसी तीसरे नंबर से हम आपको कॉल कभी नहीं करते हैं, ये बात ध्यान रखना. तो किसी भी तीसरे नंबर से हम या मेरा स्टाफ इन 2 नंबर के अलावा कोई भी नंबर इस्तेमाल नहीं कर सकता है. ओनली दीज 2 numbers फॉर कॉलिंग पर्पज. तो किसी दूसरे फोन से अगर कभी कॉल जाता है, कहने का नहीं, दिस इज नॉट गेट केमिक. ओके, या बेटा यू कैन टेल योर फ्रेंड्स. Yeah, beta Shivanshu, I will upload new practice sets of heat transfer operation soon. Sir, only 6 months left. Dhak dhak ho raha. Don't worry, Samir. Okay, if dhak dhak is there, just call me tomorrow afternoon. Okay, is it clear? Okay. So now, किसी बच्चे को my YouTube students जो ये upload हो जाएगा. So if you have any query, you can ask me. If you want to see demo sessions, demo videos, I will give you these all 700 plus. I will show you all lectures. All lecture PDF is also there. Okay, so for today that's it. And my dear students, one thing again I want to tell you at last, that if you want rank AIR 1, AIR 100, any rank between AIR 1 to 100 beta, to join your dream job, just do one thing, that is revision. Revision is the key of success. I must do my revision daily. 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 I am telling these things इन माई ऑल लेक्चर्स बेटा, तो इसका कुछ मान मर्यादा रखा करो और प्लीज बेटा रिवाइज एवरीडे, रिवीजन की आदत डालो, ठीक है. सो फॉर टुडे दैट्स इट बेटा. ऑल द बेस्ट टू ऑल ऑफ यू एंड अ वेरी वेरी हैप्पी गुड नाइट. आई एम वेटिंग टिल नेक्स्ट 15 seconds. If any additional doubt you can ask me, but first write R in comment section, then ask your doubt. Crystal clear? Aryan, Kalighatla, Sai Charan, Anubhav, Ankish, Vibhas, welcome all beta. Sameer, Anu, everyone beta, you're all welcome. So once again, all the best. Yeah beta, ask your doubt. I'm waiting. I will discuss later beta, don't worry Aryan, I will discuss later. This is doubt. Which is the lengthiest subject and need most of the revision? अब बेटा दैट इज मास ट्रांसफर ऑपरेशन. उससे बड़ा सब्जेक्ट पैदा नहीं हुआ है अभी केमिकल में, बिकॉज मेम्ब्रेन इज ऑल्सो देयर. एंड यू कैन सी आई टुक almost 16 lectures just for diffusion. Still mass transfer coefficient is left. Okay, so mass transfer operation is the longest and lengthiest subject of chemical engineering. After that second subject you can take fluid mechanics, then you can take this heat transfer operation. Okay, okay beta. So all the best to all of you, take care, love you all, and a very very happy good night to all of you beta.